Hey VBS community, this is another video from Undeniable Simulations. This is John Unden. I'm going to make a video totally impromptu video showing user requirements. I'm trying to automate an image capturing system that can be passed a target object, a range, a perspective angle, and a number of frames to capture. And then we want to generate and save images in a 360 view around the target. Okay, so let's break this down real quick. First thing we're going to need to do is make a function. And the only pre-work I've done on this is proof of concept with the screen capturing stuff. I'm able to have VBS capture screenshots. So I'll cover that, and I'll also cover creating this function. So we're going to go ahead and just make a baseline for our function. What I usually do is I start with how am I going to call this function. So let's go ahead and set that up. We want some kind of array to pass into, and it's probably going to be a spawn and not a call. Check out my earlier videos if you want to know the difference between a spawn and a call. Essentially a spawn, I like to think of it as a shotgun approach to coding where it creates threads that run in parallel. Where a call is a serialized operation and can provide some kind of return feedback. So if for instance, if I want to call a function, call check my mail, it could return an envelope to me or a letter, right? So it's going to go out and check my mail, do the function, and then what I would do is say variable my mail equals whatever I get back from this checking my mail, right? So my mail equals this, and let's say my mail is envelope 1, and after running function check my mail, it returns envelope 1. My mail will become envelope 1. I could spell or type. All right. So that's kind of how calling a function works, and it's all serial. It will not continue running the code until all of the function check my mail is complete, and then it will return something and go on to the next line of code. If you spawn check my mail, it will run. You won't be able to give it a return, so you'd have to get rid of this. It's just pretty much like a void, in my opinion, if you know C++. And so if you spawn check my mail, it will go out and you could say, let's do check my mail 1, check my mail 2. It will do both of these at the same exact time in parallel with all the other code that's running. So it will, if you're running code from top to bottom, it'll do line 1. Then it'll hit this. It will spawn line check my mail 1, check my mail 2. It'll do those kind of almost instantaneously at the same time, and then line 2, right? But it doesn't. It's kind of firing these all out in parallel. How can I illustrate this? So I'm going to use spawn because spawn you can actually do something while you have spawned something in your spawn code. Let's say I had a code block that looks something like this, and this is my spawned code. I can use something called sleep, and I can say 1 second, and it will pause 1 second within the spawn code. It will do this. It will do this line. It will sleep 1 second, and then it'll do this line. All right, so that's how you can kind of control the order of operations within a spawn using sleeps. All right, so that's just kind of a quick refresher. We're going to go ahead and spawn this because I plan on using a lot of sleeps because I want total control of the timing in this. So let's go ahead and start it out. I'll start with a comment that I can copy and paste later. Here is an array. I'm going to spawn some function called function underscore my initials underscore, and I want to call this game control. I'll tell you, picking the name for variables is probably the longest thing a coder can do. I want it to make sense going forward. 360 view around the target. I'm just going to call it target cam. Actually, it's going to capture something, so let's call it a capture cam. All right, and I can do, let's do capture cam 360 because maybe we have different capture cams. All right, so that's what I'm going to use to call it. That means my function is going to need to be named this. I use copy and paste so I don't have typographical errors, which I almost always have. I'm going to set this function equal to whatever's in these braces. All right, so great. And what are the things I need to pass to this function? I need to pass a target. I'm just going to copy that. And these are just notes, like for me. All right, so I've already set up some variables. And usually when I do this, I'm going to say my target, because target and distance are. There we go. Hey, I did it. All right, we're going to put underbar. Oh, well, I tried. Underbar. Okay, so I underbarred all of these. And now we have local variables. And what are they going to equal? My target is going to equal, let's go ahead and pull it out, this, select 0. That's the very first thing, index 0. In case you're new to arrays, I'll just go ahead and put this out in front of it. 0, 1, 2, 3. Alright, these are the index. Okay, so let's just go and continue on. Let's see if we can follow on with this. This, select what? 1. This, select 2. Just copy and paste, that would make more sense. 3. Okay. So now that's it. I passed all my variables into my function. That part's done. That was easy. Okay, so now I have these variables that I'm going to use, and this command can be used from the dev console or a waypoint or something else. So more than likely, we're probably going to tie this to a drone's waypoint or something like that. Whatever's taking these pictures, you know, we may even need to add to this. Who's taking the picture, and I'm almost certain that that's going to be the case. So let's just go ahead and plan for that, and we're just going to say all right, so now I got to go rejigger all this and just go shooter equals, and I'm just going to offset all these. In fact, what I could just do is I'm just going to do it quickly by doing it quickly. Figure out all the fancy out of the box stuff later. Right now, let's just get it done. Alright, and so we're just going to paste this in here into a 4. Alright, because now 0, 1, 2, 3, and 4. And anything grayed out is just a comment. It's just notes. Alright, so now we're bringing the shooter in as well. I'm not sure how we're going to use that yet, but I'm assuming it's going to be something to do with the angle to the target. You know, there's going to be multiple instances where I may just want to take a picture from the target itself, or there might be a specific perspective angle that I want, in which case there's lots of different ways I could handle that. I could actually create some kind of thing, object at this location and put a camera there, or I could probably just, you know, and then attach my camera to this object and then shoot the picture that just happens to be that angle. I don't know. I'm just thinking out loud. I'm actually doing this in real time. I haven't really planned this out. So let's just go. All right. So we have these things. What do I want to do with them? I want to identify a target object. So let's go. I have some camera creation code already that I've done here. We want to also, I'm going to pull this in. This is very good. We want to hide the user interface. I may not use that here, but I'm just gathering my tools I need to arrange them later. So if you've already got code, might as well use it. So I'm going to hide the user interface for this. So in my mind, I have some target object. Let's go ahead and look at our capture code. Here is camera code and waypoint. So this is taking the camera, creating it, and then putting it at a start point, and then we want to move it to a waypoint. So let's go ahead and just grab this code here. I'll plop this in here, just so I have it. I'll rearrange things later, and then I also need, I'm going to use this 1 meter red sphere as a waypoint. So I'm going to grab this too, because what this does, this should actually be 10 meter. It's going to hide all the 10 meter red spheres that are in the camera network, camera waypoints. So we're not seeing all of our helper items. So it's done when the system starts running. So let's just go ahead and put this outside of everything, and we're just going to create its own spawn right now to do this immediately upon mission start. So we're going to spawn curly brace, take all this crap. Oops, and this. Alright, so what did I just do? I don't know why I did that. I just want to spawn. Oh, it automatically created that. Okay, so as soon as the mission starts, we're going to hide all these helper spheres that I'm going to use. Make sure you use the right one. I'm going to use 10 meter red so you can see it far. And we're going to disable geo on all those spheres so that we don't see them, they become invisible. Alright, that's going to be on init. Anything that's spawned with no, doesn't need to be called, because the software on init is going to call this on its own. It's going to spawn it when it initializes, because it's in an init.sqf file. Okay. So now we've got some stuff to work with. We've got a hide UI. We're going to create a camera at some object called sphere1. We're going to use this internal back. This is all just part of creating a camera in VBS. Cam set target. Now here's the target for the player. We're going to be looking at the player, and we're going to cam commit 0. So the original target, we're just creating a camera, right? And it's going to be looking at the player just because you got to have it look at something, or it's just going to stare off randomly. I like to control that. We're going to make it the player. This is going to happen instantaneously. It creates the camera, right? Then what we're going to do is we're going to get this destination, which is our sphere that we'll create in the scenario, and that's where we're going to want to move it to. All right, and then what we're going to do is cam create some camera, which is the name of our camera, is going to cam create at the position of the sphere. And we're going to have it target some other object, and we're going to have it do this instantly. Okay, so I'm thinking already, and this is code I use from my how to create scripted waypoints video. So what we know in that video is we had a red sphere, we made a camera, and we moved it to another sphere, and then we moved it to another sphere with another destination, and this actually controls the amount of time it's going to take to get to that place. So in this case, what we're going to do is we're going to take some pictures very fast. We want this to be quick. It's not going to be a long commit. So what I'd like to do is break this down and not make it so difficult by let's just have it create spheres where we want the camera to be based on our input, how many frames. Let's create these spheres, and then store the location of those spheres, and then have the camera jump to each one of those spheres, targeting the target object, and then taking a screenshot in between each. I mean, that's basically what we want to do. So, and we have to infer some things, that the number of frames to capture is also going to determine how many slices of that 360-degree pie that we're going to cut to take these images. So if we want 360 frames, it's going to take one picture every degree of the circle around the object. That's a little excessive. So we're just going to do 4. All right. So for now, let's forget all of this stuff right now, and let's focus on that. How do we just make some, and I'm going to comment all of this stuff out. How do we get to create these spheres where we want them? Okay. Well, how do we create a sphere? Let's go figure that out. I'm going to go into VBS. And I've got some people walking around here who've seen this battle space before. And I have some code in here somewhere to create a sphere or create something. You can see up here is a scripting reference. I don't know why my colors are gone from here, but let's look for create vehicle. So it's true. ASL positions turbos ASL requires a special parameter to be set to can collide. Creates an object on the ground regardless. Default's false. Let's make that false. And that's the second one. Let's try that. Ah, haha. Yeah, that was what was doing it. So now we would achieved our objective. We created a red sphere at his feet. Perfect. Now let's do that. And what we want to do, can we do a get pause, Tom? Let's see if that works. I doubt it. Let me close this. I got to get rid of the sphere so I can see what I'm doing. If this works, that makes things a little easier, I think. Maybe. Get pause, Tom. Hey, get pause works too. Okay, good. Let's delete the sphere again. I'm doing this in long form so you guys can see the process. Get everything working in the dev console where you get real-time feedback, and then you go and commit it to code in your file. There's no reason to write code in your file if it doesn't even work in the dev console. Okay, so we've got this sphere that's being created. I'm going to take that into my file now because I want to preserve what I just did. And we're going to replace this create vehicle with this code. And I don't really care right now about calling it anything. Actually, I'm going to call it my sphere. All right. The right capital case. So my sphere equals, let's see, this stuff. And Tom, we're not going to do it at Tom. We're going to do it at my target. Okay, so all this stuff should be good. Don't forget the semicolon at the end. So if I pass Tom into here, I should get a sphere created at his location. But what we want to do is not put it at Tom's feet. We want to offset it from Tom. Well, let's make our sphere where we want it. And we could just call my function or my code. Now I'm going to move this sphere where I want it. I'm going to name it too, just so I can work with it and call this sphere 0. And I'm going to unlock its position because, for whatever reason, they're co-located. It's making it difficult. So let's just hold Alt and D. to move it to the right. ASD. There we go. So we got it off of them. So now our sphere is to the right of this guy, Tom. Let's go to dev console. And our sphere 0. We got model to world. What is world to model? Let's go with sphere 0 world to model position Tom. There we go. So this is our offset to Tom right now. And the one that's very obvious is this one is negative 2.5 meters. So what we can discern from this is that if Tom is facing to the front, negative 2.5 meters is this way. So let's look at Tom, and we have just moved the sphere to his left, negative 2.5 meters. We can imagine a number line here. Negative 2.5 meters is here, positive 2.5 is over here. Let's test that theory. Dev console. We're just going to manually move the sphere. Again, I'm going to hold Alt, and I'm going to hit A this time to move it back the other direction. And we should see that it's gone to a positive value for X there. Yeah, so now we're positive 3.5 meters to his left. So now we have the orientation correct. We can figure out the orientation of Tom. While you're looking at him, positive values are to the right, negative values are to the left. And let's figure out forward and back too, just for that sake. So we're going to put this back, holding Alt, move it back to Tom, and let's push W to move it in front of him. Let's see where that puts us. Our offset is negative 2 is in front of him, so it's weird. Positive is behind him, and negative is in front of him. Let's just test that theory. I'll move it back behind him. That negative 2 should become a positive number now, and it is. It's positive 3. So let's use distance, target, angle, won't worry about yet. In frames, we are going to use that. Okay, so this is how I'm going to create my my sphere. So what I want to do is I see a for condition here because the number of frames, I'm going to run this that many times. So I'm going to create a for loop for I from 0 to my frames minus 1. Do the following. And let's put this in parentheses so it knows that that's one calculation. So let's say I want 4 frames, and since we're starting at 0, I have to drop it back 1. All right, so we're going to do 0, 1, 2, and 3 for I, incrementing. Right? We know we're going to do 360 divided by 4. It's going to be our angles. So do we have a way to do a polar positioning? Let's figure that out. See what comes up. Rel pause. Interesting. Rel pause returns a position that is specified distance and compass direction from the given position. I wonder if there's an opposite of that will give me relative model pause. Interesting. Find a position 5 meters away from the player along azimuth, blah, blah, blah. Perfect. That is exactly what I want because that position is where I'm going to place my camera. Very freaking cool. Okay, we're using this. What is it? Starts at the position of the previous example, then moves along 10 meters. Pause equals player 5, 110. Starts at the position from the previous example. Oh, it's an offset. Distance, direction, offset. Point, object, number, number, number. Object, number, number, and then this is number, so this is offset. Add additional offset to a 90-degree angle added to the relative position. I'm going to grab this guy. This is where I want the position 5 meters away from the target along a certain axis. All right, that's great. Let's grab that. drop it in. Am I going to use it here or just like this? No, because what we're going to do is my target is going to become this. And we already know the distance is going to be sent to us, so let's go my distance. And we're going to figure out the angle from my frames. We're going to keep this, we're going to make this a vertical angle. We'll figure that out later. And maybe I should clarify this variable. Let's see, am I using my angle anywhere? No, but I am going to change it here at the top, my vert angle, and I'm going to change this to my vert angle inside the loop, because it's going to run this 4 times, right? So each time we run it, first time we run it, I'm going to calculate my angle is angle. Let's just call it my, just to keep with it, horizontal angle equals 360 degrees divided by my frames. So that's not my angle yet, is it? Because that's just going to give me the different angles. So we're going to get 90. My horizontal angle is going to equal 90, right? So what I'm going to need to do is get direction of the target first, and then add my horizontal angle to it each time this runs. So I need another variable called my current angle equals, and just for scope, I'm going to go ahead and declare these up here, just so I can use them wherever. Just put 0. And we'll just declare this as 0 to initialize. We don't really need to initialize. Yeah, I mean, you got to put something in there. So my current angle equals, we know I is 0 right now. So get direction, target. So when I is 0 plus I, right? We're going to add I to it. No, plus I. Dummy. Just kidding. All right. So plus I. So great. So now we have my current angle for this iteration of this loop. That's why it's current. So for the first one, I is 0, and let's say we've determined that we want frames to be, I want 4 frames. Has nothing to do with this select 4. That's just a random coincidence. But let's say that I fed in 4 frames. I'm going to take 360 divided by 4. That's going to give me 90 degrees. And then what I'm going to do is take my target direction. Let's say he's facing 0. And I'm going to add I to it, which is currently 0 on this iteration. So we're going to put one of these balls at my current angle each time we run this. And then we're going to get some position, right? Which is cool because now, and I need to do this before I create my sphere. Now that I have my pause, I am just simply going to put the sphere at the pause, right? So this is where I'm going to create this, and I'm going to do this how many times? 4 times. My frames minus 1, so 0, 1, 2, and 3. 1, 2, and 3. That's 4 total. It's going to run this loop. All right, and it's going to create a sphere at the position, and each time this iterates, it's because we're using I, if I've syntaxed this right, which I may not have. It should create 4 spheres around Tom. Okay, so now let's figure out what information do we call. We don't really need the shooter yet. I could put anything in there. So let's go and create, while I'm looking at this, what is our call going to look like? And I'm just going to do, it doesn't matter because we're not using shooters. I'm going to put a 0 in here. My target is Tom. My distance, we want 5 meters. My vertical angle, it doesn't matter. We're not using that variable yet. We'll just put that at 0. My frames, we want 4. All right, that's what our call is going to look like. I'm going to save this as an example. Example. All right. As it sits right now, I'm going to say as of, time is it 11:03 a.m. on 10, what is the date today? 26, 24. Of course, this will update later as we add more things to this variable, but for right now I have something to copy and paste when I want to run this. I don't have to think about it. If I want to run it a month from now, it's all there. And this should run. All right, so now my function should just run and create me 4 spheres. So let's see. You guys have been watching the video. If you're just fast forwarding to this position, what I'm about to do is do some debugging, and I'm going to host this. You have to run it in host mode. All right. You also have to have something else set up in your Bohemia Interactive 24.1 plugin 64 and optional. So you're going to look in optional, script debugger, grab this file, script debugger, copy it, all right, and you're going to want to drop it into plugin 64, and there's mine, all right. And that's going to do something cool for you. That's going to allow you to see this little thing here. You have to be in host mode. We're going to open our battle space. Let's find our battle space. It's this one. And this is the init file. Here we go. This is all we're looking at here. Is debugging this. So if you're familiar with C++ or whatever, and you've ever used a debugger, you can come in here and put a breakpoint in, and let's take a look and see what's actually happening. My theory is that there's a problem with the target, the distance, or the current angle, and our pause is not getting returned properly so that we can create our sphere where we needed to create it. So that being said, I'm going to hit this connect debugger, right? And I don't need to record the AR. I'm going to skip the briefing. I'm going to be this guy. I'm going to hit OK. And it's going to load. Now we're actually running our mission, but it's going to work the same way. So what I'm going to do now, it's a little confusing, drop this over here, put this over here. I'm going to check my recording and make sure the screen looks right. Yes, it does. All right, so now from the debugger, or the dev console, I'm going to call my function, which I'm glad I made this cheat sheet. There's my function. I'm going to drop this in, and I'm going to run it so that I can see what's going on the screen. It's going to pause everything as soon as it breaks. Make sure I'm connected. Yeah, I am connected because it's telling me to disconnect it, execute it, and it broke. I'll try to make it bigger so you can see it. Okay, and that's good. It means this actually ran, and now what I can do is I can look over, I can hover over each one of these, or I can go to my memory watcher. I can look at my local variables. I like using the memory watcher, and I'm going to go ahead and put my variables in here. So let's look at, as I come to them, my horizontal angle is 0. What are my frames? 4. What's my current angle? What's the pause I'm getting? What's my sphere doesn't really matter. I don't need to put that in there. Okay, so what I want to do is keep track of these, and it's only going to tell me the line prior to where this is. So I'm going to hit this little forward button, step over the current line, All right, and it's going to move my little arrow down one spot, and we'll fill in what my horizontal angle is. Well, oh, let's look at I as well. I should have put that in there first. Under bar I. 0. So I is 0. Right, I'm going to click forward once, and I think there's a hotkey for that, which is F10. So I'm just going to hit F10 to go to the next line. But now my horizontal angle is 90. All right, so this is correct now. For this line, it's been completed because the arrow's about to read this line. All right, and so my horizontal angle is already calculated. 360 divided by my frames, which is 4, is 90. This is correct. Let's see what my current angle is. My current angle, scalar. That's not good. That's the problem. We just found an issue. My current angle is still any. And so when we pass any into this call, we're getting nothing back. So y is get direction target. Let's figure out what this is. Plus I. Not working. Let's just plug this in here and see what it gives me. Scalar. Is it a syntax thing? What about get direction target? What's get direction target? Scalar. Why isn't that working? We can see the problem already. And if you figured it out before I did, kudos to you. 50 points for House Gryffindor. You get an award. I didn't use my. And this is the reason why I copy and paste. I try to copy and paste everything, and I beat myself up when I don't, because I cause stupid problems like this. Notice it says target, not my target. That is the problem. I can disconnect now, close my debugger. I'm going to close this, and I'm going to go back to my editor. Or you can stay in that mode and just use your debugger constantly. To me, I only use it when I need, really can't find the problem. But that's how helpful the debugger is at finding issues, and it just found my problem. The problem was I broke my own process, which should be copy and paste variables, don't type them in. It's my target. Bam. That's fixed now. Save. Run it. That was a very important lesson, guys, and I hope you got a lot out of that. Let's run this now. I'm going to hit run. I'm doing a lot of keyboard shortcuts. H, as in hotel, runs the application. M opens the map and toggles you through admin mode. But you are taking this very advanced class, therefore you should already know that stuff. So I'm going to go ahead and highlight my call. Dev console. It's already in there, right? I'm just going to rerun that. And what we should see, hopefully if this works, is 4 spheres show up around him at 5 meters spacing. Bam. Uh-oh. We have a problem. We created 4 spheres, but they're all on top of each other. 1, 2, 3, 4. You can see them stacked up there. So we are not iterating I for some reason. Problem I just identified. It should be plus I times 9 times my horizontal angle. Okay. And you guys probably saw that way before I did, and kudos to you if you did. That means you're a very experienced programmer. But so what I should get here is when I is 0, I'll get 4 is my angle. 360 divided by 4, it should give me 90, right? So what I'm going to do is take 0 times 90 is 0, so we're going to add 0 to it. So the first angle is going to be 0, whatever the target's facing, right? When I becomes 1, we're going to say 1 times my angle 90. We're going to add 90 degrees to wherever my target's facing. So this, in theory, should work flawlessly now. Let's hope. I'm just going to run this. Now that I've made a change, though, I will update this. This is not run unless you connect it. So I'm not going to connect it. I don't know. Maybe I should for good practices, but I'm pretty confident this is going to work. Let's go ahead and have to restart it because I made a change. Anytime you make a change to your code, the process is in the battle space, and restart the battle space. When you're using the debugger, unfortunately, you need to update your code over here. If you're not going to actually run the debugger, you don't really need to do anything with it, but it's a good habit to update this, and you control whether you connect it or disconnect it. I like to make sure when I'm not using it, it's disconnected, so I don't accidentally type stuff and it ends up messing with my code. So for that being said, I'm going to run this now. I don't expect any problems. If I do get a problem, I've got the debugger there. I can just go ahead and run another instance of it. All right, so let's take a look here. Dev console. Now I'm just going to rerun my function, and hopefully we'll get red circle, red, red, and red. Hey, it worked. Hot dog. Look at that. Now those are going to be my camera positions. All right, so we are going to make a camera here, take a picture of this guy from this angle, from this angle, from this angle, and then from this angle. Alright? And I think just for the sake of making this look a little bit better, I'm going to bring these spheres off of ground level about 1 meter. So let's go ahead and end the battle space now because I'm about to make changes. I'm going to keep working with the debugger open because I feel like the more I do this, the more complicated it's going to get. I'm going to need it more often. So what I am going to do though here is for the pause, I'm just going to make a new variable temporarily. Call this we'll call this base pause. How about ground pause? Let's just spell it. So I'll mess it up. Ground pause equals this. Then what I'm going to do is convert ground pause to an elevated position. Ground pause equals there's probably an easier way to do this, but I'm just going to do it the long way. Not mess up. And let's copy and paste. Ground pause. Select 0. I'll explain this in a second. Once I get it written out. Select 1. Select 2. Okay, so what I'm going to do is basically take out the ground. I'm taking the pause array and I'm breaking it down into its x, y, and z. 0, 1, and 2 are the x, y, and z coordinates of this pause, which I've now made the ground pause. We're going to call this elevated pause. Elevated pause equals whatever you got for ground pause, fill in whatever you get for ground pause there, fill in whatever you get for ground pause for x, for y, but for z, we're going to do whatever you got for this coordinate plus 1 meter. Alright, so we're going to elevate it 1 meter off the ground. And so now what we want to do is create, not at pause, but elevated pause, our sphere. Let's see. Let's see if this works. Let's run it. It may not because it's an object, and it may not allow it to float in the air. So let's just see. We're just going to call our function again. Here we go. So now what we've just done is we have these spheres that are floating in the air. All right. So our pitch to target right now should be basically 0. We're center of mass with the target. All right, well, that's great. We're making progress. I'm going to end the battle space. There's nothing else I need to do in here right now. So good. So now we have these spheres. And the cool thing about this is we're going to do all of this in one shot, like in one go. We're going to, since we're already running this for as many frames as we want, now that we've created a sphere at this location, let's create a camera at this location. We already had that code here. Copy it and paste it inside of our loop. All right. And instead of cam creating at sphere 1, we're going to create it at my sphere, because that's the location of my sphere. We just created this sphere, and while it's still still running, and while it's still named my sphere in code, and it's still in scope, we can call this cam to create it at the position of my sphere. Now, this is all correct. The target is going to be what? Well, let me copy and paste and not write target like a dummy again. My target is what we're targeting. And we're going to do this immediately, cam commit immediately. But then after we do that, now we're going to do some screenshotting to the wiki. And we'll just look it up, VBS screenshot. I'll just type in screenshot. All right, here's the command. You can look this up for yourself. But I'm using the example. I've already created a file folder. You don't have to. It'll make it for you. But let's use this one. Folder name and file, we want a JPEG at 256 by 256. Now I guarantee you if you're using an unsupported file size or a screen size like I am in 4K, it probably won't work. If your monitor size is bigger than 1080p, this 256 probably won't work for you. It'll just take it at native 4K. That's okay. Let me go ahead and drop this in my code. I'm going to take a screenshot. And all I need to do now, and I like PNGs, I'm going to PNG. All right, that's the file type, PNG. And I'm going to my file name and my folder spaces. I'm going to go up, and right away, you see this screenshots. If you don't have screenshots, it will create it as soon as you call this command. But that's okay. So we want a folder. You can create it yourself. Make sure it's spelled properly. Screenshots. I named it AI generated. All right. And then there's the screenshots I've taken. Let me go ahead and blank those out so we can just start fresh. I've tried with BMPs, JPEGs, and PNGs. I'm going to get rid of them. But AI generated. Let's copy the name of that. We're going to drop. That's our folder name. So you could just name it this. Pick a file name. We're going to call this Tom 360. And honestly, like we could format this to have a different name. From here, update this since I made so many changes. So I'm just going to leave my screen alone. Dev console. Take the pictures, close it back to player mode, and just wait 5 seconds. All right, we should have our screenshots now. Let's take a look and see if we got them. There's our screenshots. And we took the first, and you see some hands. So we took it too fast. We go to the second one, third one, fourth one. All right, so we're still taking it a little too fast to start, but we are getting our pictures. It's starting to come along. I'm going to delete those. End battle space. Let's sleep one whole second here before we take the first picture. And then we can take the other ones faster. Run our command, close the dev console, hit escape, and that way we've got no GUI interface showing up. 1, 2, 3, 4. And hopefully we've taken those 4 pictures now. Hit escape and go check my file. Here are 4 pictures. 1, 2, 3, 4. All right, we did it. Now the only thing I'm going to do is hide the red spheres. So let me go ahead and clean up my pictures again. So we know we're starting with a fresh slate, Tom 1, 2, 3, and 4. Let's go in here and we already have this code in here running at the beginning of our to get rid of any spheres when we start our mission. So let's take the same sphere, disable geo true, and apply that as soon as we've created our sphere. Let's get rid of it. Let's hide it. So we're going to create it, hide it, and now we shouldn't see any of our spheres instead of my sphere. So let me actually call my sphere disable geo true and run it again. I fully expect now when I run this code But we won't see any of those spheres we created. Wait 5 seconds. 4, 3, 2, 1. We got a picture of Tom. Smile, Tom. All right. Let's see what we got for pictures of Tom. There are no spheres in the picture. 1, 2, 3, and 4. We do, however, see the blue 4 radio, which we can disable. Again, I am running this in full-on mode. If I ran this from the RTE, my pictures would not have that in there. So let's go ahead and do that just to make sure that we've got a good solution. I'm going to delete my pictures, say goodbye to Tom for a second. I'm going to go back. Now that I don't need my debugger anymore, I'm going to run this in the editor. If you don't want to see that blue 4, you can, when you run your launcher, you can disable the blue 4 radio. Now I'm just going to hit H to run from the debugger now, or from the RTE, real-time editor, map, run my code, execute it, close it, go back to my player view and just wait patiently 5 seconds. It should take 4 pictures. 1, 2, 3, 4. Let's take a look at what we got. I did see a red sphere pop in there. We could have a little bit of a timing issue, but nope. We got 4 pictures with no red spheres around Tom. That's great. We saved them all. All right, good. Let's try taking more pictures. Dev console. Now, I want to take pictures of Tom. Let's go with 7 meters away. I don't want to run into my tent. Let's just do 6. And let's do, instead of 4 pictures, let's take 10. Execute. And wait patiently 5 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so let's see, did we get 10 pictures of Tom from those different angles? Yes, we did. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 pictures of Tom. That, guys, is mission complete. We could go into elevation, but the process is still the same. You know, if you're going to send it, we have the backbone structure set up to send it a shooter, which could be your drone, right? And so let's talk that through. Instead of taking pictures at our sphere, which would be where we're going to create our camera at our sphere, if we wanted to take a picture from a shooter, which could be a drone or something else, then you know, that's really up to you to engineer how you want that to look. Do you want the pictures to be from the drone's location, 360 degrees, circling from the drone to the target? I mean, there's a lot of stuff you got to figure out there on what you want to do, and how you want that to happen. But you could potentially replace where you create the camera from. Instead of at a sphere, you could create the camera at a known thing and send the drone or the aircraft or the tank or whatever you want to be the shooter of the picture, the cameraman, send that in here. It's already set to 0, so shooter would become get pause, create cam at get pause shooter. This. So you would do something that looks like this. Nope. I'm just deleting this temporarily. Nil equals that, and that would spawn your function when you hit the alpha radio button. I'm going to cancel that. Make sure it didn't save it. Good. But yeah, that's it, guys. Good class. I learned a lot. Hopefully you learned a lot. And now I get the joy of editing all this together for you into a video that makes sense and doesn't last forever. See ya.